Hello everyone, I am Kaisha Cadagat from Group 2 along with Mark Joseph Jose, Maxine de Guzman, Nian Borja, and Emmanuel Fernando. We are going to tackle about the 6 trigonometric ratios and the angle of elevation and depression. But today I am going to make an introduction about the 6 trigonometric ratios that you will be doing a lot in higher grades and in college. There are 6 trigonometric ratios, and in order to remember the first 3 ratios, you will need to remember the acronym SOHCAHTOA. SOHCAHTOA is a mnemonic device helpful for remembering what ratio goes with which function. SO means sine is opposite over hypotenuse. Ka means cosine is adjacent over hypotenuse. TOA means tangent is opposite over adjacent. Now for the other 3, the cosecant is the opposite of the sine. The secant is the opposite of the cosine. The cotangent is the opposite of the tangent.
So let's have this example. We have here a right triangle. The longest leg is our hypotenuse, which is 13 feet. To make sure, make an imaginary line starting from here to 13. To find our opposite, let's make an imaginary line starting from the angle to here. So this is where our opposite located, which is the 5 feet. Again, 13 feet is our hypotenuse, 5 feet is our opposite. So our last side is our adjacent, or the 12 feet. So how are we going to answer this one? By using the formula SOHCAHTOA. SO stands for sine, opposite, and hypotenuse. Ka stands for cosine, adjacent, and hypotenuse. TOA stands for tangent, opposite, and adjacent. So we have our 6 solutions. The first 3 is sine, cos, and tan. Sine stands for opposite and hypotenuse. Cos stands for adjacent and hypotenuse, while tan is opposite and adjacent. Now for the last 3, we have cosecant, secant, and cotangent, which is CSC, SEC, COT. How does the opposite work? It's just like the other one, but opposite or reverse. Example, sine, opposite and hypotenuse. And the opposite of sine is cosecant, which is, it will be reversed into hypotenuse to opposite. Same as the others, cos is adjacent and hypotenuse, the opposite is hypotenuse and adjacent, and tan is opposite and adjacent, and reverse, adjacent and opposite. So let's start answering. How to answer this or solve this? It's just by looking at their positions in the triangle and looking at SOHCAHTOA formula. So for sine is opposite and hypotenuse, which is our opposite is 5 feet and hypotenuse is 13 feet. So we're gonna write or put or answer is 5 over 13. For cos is adjacent and hypotenuse, or our adjacent is 12 feet and hypotenuse is 13, so it's gonna be 12 over 13. For tan is opposite and adjacent, which is the opposite is 5 feet and adjacent is 12 feet, so it's gonna be 5 over 12. Now let's start on the opposite side. Cosecant, CSC, hypotenuse and opposite, which is 13 over 5. For sec or secant, hypotenuse and adjacent is 13 over 12. For cot or cotangent, adjacent and opposite, which is 12 over 5. Well, that's all about it. Now we're gonna find the trig ratios using the Pythagorean theorem. As can you see, we have a missing side, which is b. So first step, we're gonna find the missing side. We're just gonna label down 12 squared plus b squared equals to 13 squared. Now 12 times 12, because it's 12 squared, equals to 144, plus b squared equals 13 times 13, because 13 squared equals to 169. Now to find the missing side, or the b, just minus 144 minus 169 equals to 25, and which is 25 is 5, because 5 times 5. Now we have the b, which is 5. Now we're gonna answer the SOHCAHTOA. Now remember the SOHCAHTOA in our previous example. Sine is opposite in hypotenuse, which is our opposite is 12 and our hypotenuse is 13. Now our cos is adjacent in hypotenuse, which is 5 over 13. Now tan is opposite and adjacent, which is 12 over 5. In here, we're just gonna reverse, which is 13 over 12, 13 over 5, and 5 over 12. That's for our first example. Now let's move on to another example. So let's have this triangle. In here, we're gonna find again the missing side, which is b. Again, let's label again or group. 8 squared plus b squared equals to 10 squared. 8 times 8 equals to 64 plus b squared equals to 10 times 10 equals 100. So it's 64 plus b squared equals 100. Now subtract 64 to 100. The answer is 36. So the b is 6, which 6 times 6 equals to 36. So if you divide it, it's 6, or lowest term. Now for the SOHCAHTOA, or set up the ratios. Again, remember the previous one. Sine is 6 over 10, cos is 8 over 10, tan is 6 over 8. Sine can be 3 over 5, cos can be 4 over 5. Tan can be 3 over 4, which means we just lowest term everything, or the number can be divided. Now for the last trig ratios, we're just gonna reverse it, which is 5 over 3, 5 over 4, or 4 over 3. We use the lowest term numbers. Well, that's all about it. I hope you learned something.
In trigonometry, you will often encounter these three in problems: line of sight, angle of elevation, and angle of depression. Hello, I am Reyna Maxine and I'm here to tell you all what these three are. First of all, what is the line of sight? The line of sight is an imaginary line that connects the eye of an observer to the object being observed. So, say you're an observer, and there is an object right in front of you. If you imagine a straight line from your eyes to the object in front of you, that is what you call your line of sight. Now, what is the angle of elevation? The angle of elevation is the angle from the horizontal to the line of sight of the observer to the object above. In simpler terms, it is what you see above your line of sight. The angle of depression is the angle from the horizontal to the line of sight of the observer to the object below. In simpler terms, it is what you see below your line of sight. Those two angles always start on the line of sight. If it starts anywhere else, then it is no longer an angle of elevation or depression. Here is how you illustrate the two angles. One is elevation while the other is depression. Those two angles help in trying to estimate how far or how tall an object is from the observer. Keep in mind, we are only trying to estimate how far or how tall an object is, so it will not always be accurate or precise. Also, when answering problems that require those two angles, you will need to be familiar with the 6 trigonometric ratios, or else you will not be able to answer any problems requiring the two angles. How do you solve a problem using those two angles? It is simple, by using the power of triangles. Take a quick look at this illustration. See how there is actually a triangle there? The angles help in making up some sort of triangle, which then helps us solve the problem using trigonometric ratios. That is about all you need to know about the angles of elevation and depression. I hope I explained it well enough for you to understand. Let us now move on to the next part.
The first question is, a tower is 15.24 meters high. At a certain distance away from the tower, an observer determines that the angle of certain elevation to the top is 41 degrees. How far is the observer from the base of the tower? Now, how do we solve this problem? The very first thing that you need to do is to understand the problem. Then, the next thing you need to do is to draw or illustrate. You need to illustrate the problem because this will help you to solve the problem. It is stated in the problem that there is a tower and there is an observer, so you need to illustrate them. You could draw it like this, or you could use FBD or free body diagram, wherein you could put a box and label them. The next thing you need to do is to label the parts of the problem. There is one clue in the problem that says that the tower is 15.24 meters high. According to the problem, the angle of elevation is 41 degrees to the top. You can draw a straight line to represent this line of sight of the observer. Then you're going to create an angle of elevation from the top of the tower. So this is your angle of elevation. Then you label it 41 degrees. So it is stated in the last part of the problem, how far is the observer from the base of the tower. So basically, what we're looking for is the measurement from here to here. The next thing you need to identify what part of the triangle is this. So this part of the triangle is the opposite side. You need to identify what part of the triangle is this. So since this is the opposite side, we already know that this side is the adjacent. So therefore, the distance from the tower to the observer is the adjacent part of the triangle.
A tower is 15.24 meters high. At a certain distance away from the tower, an observer determines that the angle of elevation to the top is 41 degrees. How far is the observer from the base of the tower? Diagram again and the given. The missing is the distance from observer to tower. TOA is the solution. Again, we compute this manually. Tangent 41 degrees equals to 15.24 over x. Then substitute x again on the left side of this and equals to 15.24. X equals to 15.24 over tangent 41 degrees. So, we can now use the calculator. 15.24 divided by tangent 41. The answer is 17.53 meters.
First, you need to understand the problem. Then, you need to illustrate the traffic controller, tower, and the airplane. Then, you label the measurement of the tower. Then, you draw the line of sight of the traffic controller. Next is you need to draw the angle of depression. It is stated that the angle of depression is 19 degrees. Next is you need to identify which part of the triangle is this and which part of the triangle is this. This part is the adjacent and the other part is the opposite. It says at the last part of the problem that how far is the base of the tower.
From the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of 19 degrees. How far from the base of the tower is the airplane? Create a diagram again. Then the given values. And the missing is the distance from airplane to tower. The solution is TOA, means tangent equals to opposite over adjacent. We compute tangent 19 degrees equals to 120 feet over x manually. Substitute x to the left side of tangent 19 degrees and equals to 120, and substitute tangent 19 degrees to the denominator of 120. On the calculator, 120 divided by tangent 19. The answer is 348.51 feet.
So again, you need to understand the problem. Then the next thing you need to do is to illustrate the wall and the ladder. Then you need to label their measurements. Then you need to find the angle of elevation. So there's no angle of elevation stated in the problem, so meaning that's what we need to find. Next is you need to find the parts of the triangle. So this part is adjacent. And this part is the opposite.
A 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must be the ladder be situated in order to reach the top of the wall? So, we create a diagram that represents to the problem. Then, these are the given values. And the missing is the angle of elevation. The solution for this is SOH, meaning sine equals to opposite over hypotenuse. Then, we compute sine raised to -1 multiplied by 13 over 14 using calculator. Sine -1, 13 divided by 14, and equals. So the answer is 68.21 degrees.
First thing you need to do is to understand the problem. Then you need to illustrate the wall and the floodlight. Then you need to label the measurements. The wall is 39.82 feet and the distance from the wall to the exit is 51.74 feet. Then you need to find the angle of depression. So there is no angle of depression, so that means that's what we need to find. Find the parts of the triangle. So this part is the opposite side. And this part is the adjacent side.
A company safety committee has recommended that a floodlight be mounted in a parking lot so as to illuminate the employee exit. The light will be mounted on a wall 39.82 feet above the ground and 51.74 feet horizontal distance from the exit. Find the angle of depression of the floodlight. You can pause this video if you want to answer it on your own. Diagram. Then the given. The missing is the angle of depression. The solution is TOA. On the calculator, tangent -1, 39.82 divided by 51.74. Then the answer is 37.58 degrees.